In this video, we're going to talk about anonymous methods. This is part 2 in a 3-part series about lambda expressions. We'll see that anonymous methods are simply blocks of code that have no name. Now remember back at the beginning, maybe day 2, maybe day 3, I can't recall. We said that a method is a named block of code. Well, in certain situations, you can just create a block of code with no name whatsoever, making it anonymous. And up to this point, when looking at delegates in the previous video, we had to create an instance of the delegate definition. So a method already had to exist with the same method signature as the delegate. We had to create an instance of the delegate definition in order for the delegate to work. But with anonymous methods, we can avoid that step of creating a named method and instead just pass in a block of code as the parameter for the delegate. So in the previous video, we looked at a few examples of delegates. Using anonymous methods now, we can shorten the syntax just a little bit. Again, a building block towards lambda expressions. Let's take a look at 2 examples and modify them to use anonymous methods. So here's the first example from yesterday, or from the previous video rather. Here again, we had to actually define the delegate function by declaring the method signature, the return value, and the input parameters. And we called this delegate a function for a string. So that's just like what we did in the previous video. Our perform operation on string array is exactly the same. Even the delegate function for string operation that's passed in and used within our perform operation on string array. But then you can see here in the static void main, things get a little bit different. Now, previously we had this starts with a method that we created. That is completely gone now, and in its place, what we do is define the body of it right here. And in this particular example, what I've done is to give you a longer form, and I'm going to come back and show you a shorter form in just a second. But you can see how using this format, it makes it obvious that I'm kind of creating an instance of this function for string delegate. And here we have basically the anonymous delegate part of it that, again, we'll use in a moment. But what I've done is basically just save that anonymous method into a variable that I then pass in when calling perform operation on string array. I just did this to make it obvious that I'm essentially creating an instance of that delegate definition. Alright, so here we see that we're creating an instance of a delegate. We're going to allow an input of string, and then we're going to return basically a Boolean, whatever's returned from starts with A. Okay, so let's run the application just quickly and we get the same results as we did before. Great. So let me show you then kind of the more normal form of this, and I'm going to actually copy all of this, plop it there, and then I'm just going to take this part, copy that, and put that here. Okay, and now run the application again. Alright, we get the same results. Alright, so this is the essence of an anonymous method. We have a method with an input parameter and a body, and it returns a value. It still adheres to our definition that is then used in our ultimate method where we want to use this anonymous method, or delegate rather. But we're able to get rid of the starts with a method, which took up only in that particular case 3 lines of code, and instead just put it right in line. Now you might say, well, that's a rather small improvement. Yes, it's a small improvement, but again, it's a stepping stone to what's coming next. So just keep that in mind and continue to watch the progression. Let's do this. I have another example. Let's save what I've done here. And we're going to open up the bubble sort application, but I'm going to make some changes to it right as you and I are sitting here working on this together. I'm going to call I have a project called Bubble Sort Anonymous Methods. You should be able to download that. And here I want to show the process of removing our delegate instances here and here. Let's go ahead and just comment those out. And instead, and then for the moment, let's comment this out too. We'll get back to that in a moment. And then here, what we'll do, instead of using this sort by order amount, let's just use the body of this. And then we'll do the same to the one below it. In fact, I'm going to copy and paste some stuff in here. And notice we still get IntelliSense. That's pretty cool. All right, and we get the same results we got before. All right, so again, the gist of it is that I don't have to define my methods ahead of time. I can just inline those method definitions right in my call to a method that requires a delegate as an input parameter. Okay, let's do the same thing for, in fact, we can just get rid of this entire class that we have here. Let's just get rid of the whole thing. And I'm just going to grab the body here. That's the important part. Let's go ahead and turn that back on. We will change this out to and then open up the body, paste something in there. All right, now let's see if that works. There we go. Okay, and we get our sequence of numbers just like we did before. Okay, so this was a tiny improvement, right? Well, in the next video, we're going to finish this story. Again, this is just step 2 to a longer story. We're going to talk about lambda expressions and also talk about some pre-built delegate definitions that we can use so that we don't have to create our own. But yes, the benefit here at this moment for anonymous methods is that it does require just a little bit less code to accomplish the same thing. But the ultimate story is found in lambda expressions, which are essentially shortcuts for the anonymous methods. See you in the next video. Thank you.